Welcome to Utilizing AI, the podcast about enterprise applications for machine learning, deep learning, and other artificial intelligence topics. Each episode brings experts in enterprise infrastructure together to discuss applications of AI in today's data center. Today, we're discussing the application of DevOps principles to machine learning and MLOps. I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. You can find me on Twitter at @sfoskett. Now let's meet my co-host, Andy Thurai.
Hello, I am Andy Thurai, founder and principal at thefieldcto.com. You can find me on @Andy Thurai.
All right, hi. So I'm Gaetan Castelein, also known as GC. I'm head of marketing at Tecton. Been at the company now for about a year. At Tecton, we're building a data platform or a feature store for machine learning. So very excited to be talking about that topic with you today. And you can find us at tecton.ai.
Okay, so today's conversation is an interesting one. So we had enterprise IT, where we had all of the mature components from mainframe to three-tier to blah and all that messaging service, middleware, the whole nine yards. And then we moved from there into more of a cloud-based economy, right? And everything was about infrastructure, everything about code, everything about automation. But now we are kind of in the nasal stages of moving into the data-based economy. But the problem with that is that there's way too much of data we are getting in, and we are not using it enough to get proper insights from that. One issue could be because we don't have a good set of tools. Second issue could be that we don't know how to engage in data economy. GC, what do you think? What are the issues you're seeing?
Yeah, I think it's a great question. So generally speaking, we're seeing kind of a major shift in analytics and software engineering in the sense that over the past decade or so, we've made a lot of investments and progress in software engineering. We have all this DevOps tooling. We can now deploy applications on a daily basis, release code much faster than in the past. And in parallel to that, there's been a lot of innovation in big data and analytics. It started with like this Hadoop transformation, but there's Snowflake, the cloud data warehouse. There's Spark new processing engines. So we've really kind of beefed up our ability to manage and analyze vast amounts of data. The problem that we see is these two stacks have really evolved in different silos. And now we're getting to the point where the volume, the speed of data just becomes unmanageable with a human in the loop. And that's really where machine learning comes in. Like machine learning allows you to generate insight, inference on data at a scale where an individual human couldn't keep up. But to really benefit from machine learning, we also need to get into a mode where we can bring machine learning to production. Like we really need to be able to take that human out of the loop and build new customer-facing applications, automate new business processes using machine learning. But that also requires a huge change. It requires us to take that analytics stack and kind of converge it with that software engineering stack so that we're able to bring analytics to production. And that's a big change. And I think what's happening now, what we're seeing is all this DevOps tooling that we've built for software engineering, we don't have that for machine learning and for analytics. And all of that tooling needs to really appear on the scene. Otherwise, it is going to be increasingly difficult for us to really get machine learning to production. That's where this notion of bringing DevOps to machine learning and machine learning data really comes in.
So there's a question, there are a couple of points in there that you talked about. I want to double click. The particular ones, let me ask you the first one. You talked about having a humongous amount of data, right? That's a debatable term because some people will have megabytes of data and they say, oh my God, I got too much of data. And then a fully automated digital economy, for example, I could throw on names like Uber is one example. They not only they have a ton of data, even the number of models they get, that they cycle through. People don't realize that if I request Uber service, the amount of models they do to predict to connect me with the driver, the pricing models that they run through that often how it is, the number of models itself could be hundreds of models that they'll do. So talk about those two. What do you mean by large amount of data on the data economy? What do you think is large amount for enterprise for them to start thinking about? And second, how often models get updated and those kind of things as well?
Yeah, a great question. I think large is obviously a very relative term, but I think the point is that like the volume of data is constantly increasing and increasing pretty fast. And we now have, for example, streaming data where data comes much faster than we used to have it. And so the point where we talk about big data is really, I think, when it becomes very difficult to generate all of the insight, squeeze all the value you can from your data with human processes, right? And so that's really where automation comes into play. On your question on Uber, yeah, it's fascinating. So Tecton was founded by the original creators of the Uber Michelangelo platform. And 5 years ago, super difficult for Uber to get even one model to production. And then they decided to invest in this infrastructure for machine learning, like an MLOps platform that took care both of models and data. And that allowed them to now deploy tens of thousands of models in production and like covering a very broad range of use cases like ETA forecasting, like search pricing, like fraud detection. It's kind of been a fascinating transformation. And a lot of that was enabled by Michelangelo because what Michelangelo did was bring those DevOps processes to this process of building machine learning models and enable data scientists to build new models and get them to production quickly and reliably, just like we do with software today, right, in most organizations.
So you talked about one specific element of the streaming data coming in at a speed, the velocity that we have never seen before. Do the digital enterprises have a problem because of too much of velocity of the streaming data that's coming in, or because they have to figure out a way to integrate that with the existing data and the models? And also, because obviously when the streaming data comes in, you do mostly inference with that. But then also you got to figure out a way to get that into your data store. So your future store in the future and the models will be updated. So that whole process, walk me through that and how generally a good enterprise should do it, good digital enterprise should do it.
Yeah. And, streaming data is a super interesting change. I was at Confluent for a few years before joining Tecton, so very, very familiar with what's going on with Kafka. And I think a lot of the use cases initially for Kafka are really about application integration. It's an application team that needs to have better access to data sitting in a database that wants to build an event-driven application. And then eventually it makes its way into big data and analytics. And I think specifically in this world of analytics, what streaming data means is that you get your data much faster. Like it's no longer just available on a daily basis after a batch job. It is now coming in continuously with maybe a few seconds delay, but it's coming in very fast. And so I think the impact there is that with the speed of data coming in, it's even more difficult for humans to keep up, right? So in the past, we used to have the daily report with like, here's the batch data from yesterday, and like, here's how inventory is evolving, or here's how demand is evolving, and then a human could make that decision. Now with streaming data, you have to make these decisions and adjustments on a continual basis, and it's just not possible for humans to keep up. And so in terms of how enterprises should manage this data, I mean, I think we also see like many stages of how refined the data could be, right? So data will typically come in very raw, maybe into a data lake of some sort, and then gets refined. Many times it gets refined into, for example, a data warehouse, and that's great for BI. But then you also need to have access to this refined data for machine learning, especially if you want to automate these decisions and feed analytics into a production application. Now you've got to automate that decision-making process, and machine learning ends up being the most efficient way to do that. And so just like we have clean data for BI with the data warehouse, we think that we need that clean data for machine learning. And that's really where the feature store comes in.
This is a topic actually that came up when we were talking with Karen Lopez, Data Chick. She was talking about the fact that you need to be careful about what kind of data you've got in your system, and basically the whole process of managing data. And I think that's something maybe that people might overlook if they're thinking about bringing these things in, because I guess in a way people are used to, I think they think that it's more intelligent than it is, and it's more autonomous than it is. And yet, the whole process of data management becomes even more important when you've got a computer system in there.
Yes, absolutely. And I think a lot of the challenge we see, like data management in and of itself is already complicated enough, right? Like all these batch pipelines, super difficult to manage. How do you make sure that the data is clean, that there's no data drift, that you do great data validation at ingest. And then all of that becomes even much more complicated once you move these pipelines to production. And so building these production pipelines, which is really what enables us to refine this data for machine learning, is actually a super complicated process. And we're talking about how difficult it is to bring machine learning to production. I think a lot of time that's being lost today in production machine learning projects is actually being spent on that process of building production pipelines to serve clean, highly refined data to machine learning models.
There's a point you mentioned in there, which is very key. You said the data scientists, have this too much of data. And then from what I've seen before, look, at the end of the day, data scientists is a new crop of engineers or scientists, however you want to call it, that they are coming in on board. And given that the data economy is not at old, you don't have that many data engineers. Hence, finding a qualified, experienced, good ones is very expensive. And companies land up paying a ton of money for them. And then what I hear commonly is that about 80% of their time is spent in data management, right? Data cleansing, data management, data wrangling, finding features, all of the above, right? They spend only 20% of the time in producing the actual models, which is their job, okay? And that's in itself is issue number one, because they're only 20% efficient, right? Ish. And then another common pattern I'm seeing, which is even more problematic, is that even though they create amazing models, the engineering team or the DevOps team or the infrastructure team couldn't figure out how to get the model into production or productionizing a proper model. And then half of the models are thrown away. So which means effectively you're doing less than 10% of the models originally thought out or ideated. Why is that? And how can it be fixed?
Yeah, 10% is definitely not a great metric, great place to be at.
Right.
I think it goes back to the challenge that we were talking about at the beginning, which is we just don't have the tooling to get machine learning to production today. I mean, it's two things. It's a combination of processes and capabilities, like what does the organization look like? What are people able to do? And then on the other hand, it's like tooling. And really this notion of bringing machine learning to production is a completely new endeavor for most organizations. And so they don't have the right processes and or the right tooling in place. And it's very complicated because with a traditional application, all we need to get to production is code. And code is something that we own, we manage, we build it. So it's got relatively low entropy, and we can control it pretty easily. Models and data are a little bit different. Like models, mostly like code, mostly stateless and controllable, manageable. Data is very, very different. But you now have to treat data like code, because data is going to define your application when it comes to machine learning, in the sense that if you train your model with a different data set, the application is going to behave differently. And so you need to be able to manage that data just with the same reliability and efficiency as you've been managing code in the past. And it's way more complicated because we're not building data. We source data from a number of places. Typically, your data is imperfect. It's not always a totally known quantity, like it may drift or change over time. And yet, we have to manage this refined data we feed into our models with the same efficiency as code. And I think that's what creates a lot of these challenges, is we're not set up to manage that well today. And so if we look at these two new artifacts, models and data for machine learning, we think there's actually quite a bit of innovation in terms of getting models to production. There's platforms like Kubeflow, SageMaker, and others in that MLOps space, which are really designed to get models to production quickly and reliably. And that space is not perfect today, but there's definitely innovation and it's getting better. What is still highly problematic is tooling for data. And as long as we don't have tooling for data, it is going to be very difficult to get machine learning to production. And so what's going on there is you have a data scientist who's not a software engineer, not a data engineer. Like, they do exploration and they use notebooks and Python and like code that's mostly optimized for data exploration and experimentation. They figure out the features, they train the models, and then they pass the features to an engineering team who can re-implement that pipeline for production. But that process of handing off things to a different team for re-implementation is very inefficient and it really goes against the principles of DevOps. And so what we think we need is processes and tooling to also manage machine learning data with the same efficiency and bring DevOps to machine learning data. There's definitely a process component where we need to empower a data scientist to control the features all the way from development to production. But there's also a big tooling gap. Like to enable that, we need the right tools underneath. And that's really where Tecton is investing in bringing DevOps to machine learning data. And in support of that transition, there's like this nascent product category that's called a feature store, which is really what Tecton does. And seems to be emerging. Like we're seeing a lot of inbound inquiries and a lot of interest around feature stores. And that to me is tooling that is an essential component of that DevOps stack for machine learning, for getting operational machine learning to production. That notion of feature store. Right?
Okay, I get that. I mean, based on that explanation, almost every digital company or data enterprise company or data economy company should have the problem. But from what I'm seeing, Uber had the problem and they put a ton of money, 2-3 years ago into Michelangelo platform to build that, which came out really great. And then Lyft is doing some of that too. And then Gojek is doing that. So there are only very few companies doing this to solve this issue. Is that because other digital enterprises don't have the problem or don't have enough data, or they don't know that there is a problem, such problem exists? They are doing it the old-fashioned way without knowing there is a problem.
Yeah, great question. I think it really depends where companies are at in their operational machine learning journey. So if they're just, doing batch machine learning or like batch inference, this problem may not be as prominent. If they just have a couple of models in production, those models are not using streaming data and don't need like very fresh features, maybe this is not as much of an issue. But definitely, as companies begin to use very fresh data like streaming data sources or real-time data sources, as they begin to expand into not deploying just one model in production, but tens of models, as they expand their data science teams, this problem becomes very evident over time. And so, but there's also not really been any commercial or open source offerings in the past. And so companies had a choice to either build their own infrastructure, very much like Uber did with Michelangelo. And this is something we have seen, a number of companies actually building their own feature stores in-house, or they can do things manually like they've been doing in the past. But then building a feature store in-house is not a small investment. It's a complicated piece of technology. And it's almost like asking, hey, if you're building a BI stack, do you want to be building your own data warehouse? Like, is that the best investment dollar that you can spend? Whereas if you could buy a great data warehouse off the shelf, wouldn't that be an easier way to get there? And I think those are some of the discussions that we're having with customers is like, is it the right thing to be investing on building your own feature store, or can you just buy one, get up to speed much faster and not have to invest those engineering dollars?
And it seems like that's a nascent category in the space, this whole idea of building feature stores and building applications that would do this. But yet even though there are some companies in this space, it seems like there's a great difference between the various products in this category. Do you want to talk to that a little bit?
Yeah, I think it's fascinating. It's feature store really is like a nascent product category. Like 2, 3 years ago, there was no commercial offering available. Now there's a few companies, Tecton being one of those. There's also some interesting open source projects appearing, like Feast, for example, which is an open source project out of Gojek. But what's also obvious is that the definition of a feature store is very different across companies. And I think as an industry, we kind of need to converge on a common definition. And looking at the Tecton definition, for example, we think a feature store should cover like the build, run, manage spectrum, in the sense that it should enable data scientists to build features collaboratively, have standardized feature definitions, and then apply those to a feature store, which then allows you to run your models by automatically processing the feature values, curating those feature values, and serving them for online inference. And then all of that should be manageable with like a managed layer where you can do things like discover features, track data lineage, monitor data for things like data drift and service levels for online serving. And so for us, that's like the full spectrum. But then definitely depending on where you're at as an organization. So for example, some organizations already have production pipelines. And so they don't necessarily need a feature store to build new pipelines and new features. They really need a way to store the values, having a single source of truth of features, of data, and then being able to serve those both for online and training. And so those are two different things. Like and so some of the feature stores don't need to cover that build, run, manage spectrum, right? And some of them actually focus more on the run aspect. I think Feast would be a good example there, where the idea with Feast is that you're coming in with existing pipelines, production pipelines, and Feast is going to focus on curating the data, providing a single source of truth, and serving the data. So there's definitely many different definitions and classes of feature stores. And I think as the product category matures, we are going to see kind of a more common definition over time. But definitely very interesting to see that dynamic of like this new product category taking shape.
I know that it's an existing problem with the digital enterprises, and you know that, but a lot of companies don't know that. So meaning if you have a ton of data, if you figure out certain features, because obviously feature is the basis for a model. So when you have an idea, you have a business idea, you have a problem, figure out a problem, find out the feature set, and then create a model and try to productionize that. The critical component is identifying the future, because let's say if you have like 100 data scientists across the board, whether within your organization or even partner organizations, if they were going to be looking to solve a similar problem, there is no place they can go and take a look at saying that, okay, has this been done before? That's a major problem that some of those feature stores, including yours, solve. If they're not using you, how are they solving the problem today? Are they even looking at the problem?
So I think the question is like, how are they doing feature extraction and feature engineering today, right?
Yeah. Feature stores, feature engineering.
Yeah. Good question. I think there is tooling for like data scientists to do data exploration, and they typically use, there's data preparation tools like Alteryx. There's data engineering tools like Spark and Databricks and the notebooks. And I think all that stuff is great for like doing data exploration and experimentation on features. But what those tools don't do is get your features to production, right? And so that's where you're left with that gap of like, I do have tooling as a data scientist to do feature engineering, but I'm not empowered to get that data, those features all the way to production. And that's where the process breaks down, because that's where you have to throw your features over the wall to the separate data engineering team. And then you're dealing with like months of delays and a lot of like coordination between data scientists and data engineers. And that's where we think the process needs to become a lot simpler. And we need to empower data scientists to not just like engineer features, but really get them to production.
Well, that explains why more than 50% of the models fail not to make it to the production, right?
Yeah, for sure. Like, I don't know what the exact number is, but we do see it a lot. And like, even for the ones that do make it to production, it oftentimes just takes way too long, right? Like if it takes a year to get a model to production, by the time it's in production, your data scientists have like 10 new ideas of things that they could make better, like that they want to iterate on, but they just can't implement them. So I think it's frustrating for many teams to be stuck in that situation. Yeah.
So sort of to wrap up the conversation then, I think one of the things that happened when I was talking to you, GC, last time on our briefing is when I came to understand sort of the fundamental analogy of what you're describing to sort of what we already do in enterprise tech. You know, the fact that a feature is really sort of the AI equivalent of you know, a data point or a you know, a file, an image, all these other things that we're already used to storing. The idea that we need a specialized storage platform for features in AI suddenly just, yes, we do. Of course we need that. It made a lot of sense to me. And I think that after this discussion, I think a lot of the listeners may be saying the same thing. You know, Andy, do you want to sum up a little bit here of, you know, sort of what is this and how does it affect people and you know, how will it come into the enterprise?
Right now, most of the future store getting the features on the model to production is done very manually. It's a very cumbersome process, very manually, very inefficient. As Gigi was saying, it's not uncommon to see some of the models, even it's a kick-ass models, you know, if it is produced within a matter of weeks, you know, by the time when the DevOps teams and the infrastructure teams figure out how to get the model into production, how to keep it up to date, it could take months, if not, you know, close to a year. By then, probably that's not even a viable model. Your business model have changed. Your business problem has changed. Maybe you solved the problem, or maybe you're not even in business given the current economy, right? So not only creating a models faster should work faster, getting insights from the data, but also getting into production should be the fastest, most efficient. And that's where companies like Tecton would help.
All right. Well, thank you so much. Yeah. So, I mean, I think your observation was very accurate. Like we have, you know, but I think you compared it to storage. I think I would compare it more to like a mix between a database and a data warehouse, because ultimately what we do is we curate data, we provide highly refined data, but we also serve that data online for models, right? So it's like this highly refined analytical data that gets served online at very low latency. And so from that standpoint, it's kind of like a hybrid, I'd say, between a database and a data warehouse. But yeah, there's no question. I mean, I think you're going to see a lot of investment in the coming few years on platforms for operational machine learning, MLOps platforms, data platforms for ML, because there's such a big gap today. It has to be the future. You know, we've talked about software is eating the world, and indeed it has had a huge impact over the past decade. And we also talk about data is the new oil, which is also very accurate, but somehow these two things need to come together, right? Like analytics and the world of software and production software need to come together. And the path to get there is via machine learning and getting machine learning to production. And the path to get there is really by having better tooling and better infrastructure and investment in these MLOps or DevOps platforms for machine learning. So you know, strong fan of what's happening there. Very excited. Would be super interesting to see how this space evolves.
Well, thank you very much for joining us today. GC, where can people connect with you and follow your thoughts on enterprise AI and other topics?
Yeah, for sure. So Tecton.ai and our blog there is a great place to go. On Twitter at Tecton.ai. Those are the two best places to follow us.
Great. And Andy?
You can find me on Twitter at Andy Thurai, or you can find me on my website. That's thefieldcto.com. Again, that's thefieldcto.com.
Thanks a lot. And you can find me on Twitter at @sfoskett, and you'll find my writing at gestaltit.com. Thank you for listening to the Utilizing AI podcast. If you enjoyed the discussion, please remember to subscribe, rate, and review the show in iTunes, since that really does help our visibility. And please share this show with your friends. This podcast was brought to you by GestaltIT.com, your home for IT coverage across the enterprise, and thefieldcto.com. For show notes and more episodes, go to utilizing-ai.com or find us on Twitter at utilizing_AI. Thanks, and we'll see you next time.